Alright, quiz 8.1, 8.2, I combined them. Just doing some confidence intervals for proportions. Okay. So, yada yada. 2016 survey, 800 registered voters, 413 support California Proposition 56. We're going to do what the media does, a 95% confidence interval for the true proportion of registered voters that support Prop 56. Okay, so we're doing a confidence interval. Now, obviously this is from 8.1, 8.2 because it says it on the top, but if you're taking the exam or the final or whatever you're taking, it may not specify, and you have to decide. You're doing a confidence interval for sure, and you have two options: proportions or means. Are they talking about percentages of people doing something or the averages of something? They're looking for the proportion, as it says it right there, or percentage, same thing, of registered voters that support Prop 56. So that's an indication that we are doing proportion, a confidence interval for proportions. And you look on your formula sheet and know that your one for means has an X bar and S in it for mean, sample mean, and sample standard deviation. Your proportion ones is the other one basically that has P hats and Q hats in it. So those are the two formulas for confidence intervals against proportions and means, and here we're doing proportions of registered voters who are going to support this proposition. All right, what do we need? I need P hat, I need Q hat, I need N, and I need Z. Where's my calculator? Hold on. All right, P hat we're going to have to compute ourselves. It's sometimes they give you the percentage. Sometimes they tell you like 48% of the sample supported the proposition, and you're just converting that to a decimal. Sometimes you have to compute it on your own. In this case, we do. They didn't tell us any percentage of the sample. They told us 413 out of 800 in the sample supported the prop. All right, and so we're going to do P hat, compute it on our own. 413 divided by 800, and I get 0.51625. These are proportions, so we'll round out to 3 places. 51.6% of our sample supported it, and our best guess would be that, given all the information, 51.6% of all registered voters will support it, meaning it should pass if our prediction is correct. We're going to go further and do a confidence interval. Q hat is going to be 1 minus 516. Oh, 484. Or N, make sure you're reading this problem carefully. It's not the 413, it is the 800 registered voters that were surveyed, so your N is 800 here. Z. Z depends on the confidence levels. These are those boundaries that contain a certain probability or percentage in the middle, and that's based on the confidence level. They want a confidence level of 95, so we're going to be looking for Z-scores that have 95% probability in the middle, and then we'll be translating that. We're not going to be drawing this all out, but we're going to be translating that to some boundaries for proportions. That'll be 0.516 in the middle, and then we're going to go out and to the left and right a certain margin of error that we're going to compute. That's going to be based on all this. That'll tell us how far to go out to the left and right from that 51.6 to get some boundaries, and then say we're 95% certain that the true percentage will be within there, and then we can make our predictions about whether the prop is going to pass or not. Okay, anyway, I don't need to do that, but I definitely want to have the picture here so I can kind of visualize what my probabilities are, because I'm going to be using inverse norm, and I'm not going to be plugging in 0.95, I'm going to be plugging in tail probabilities. Let me get this one detailed since it's a quiz. I'm going to get each tail. It's symmetric, so they're identical areas, and to get them I want to use a complement rule, 1 minus 0.95. That would mean 5% outside combined, and I want to cut that in half. I'll get 0.025. That's in each tail. And then what I need to do is inverse norm takes the area to the left, and I'll just plug in that 0.025, and that'll be the area to the left of this score, and I'll get that z-score on the left, the -1. The critical value that I'm plugging into the formula is the positive of that. It doesn't really matter because we are going to be doing plus or minus anyway, so the sign won't matter. We are going to be doing both signs related to these plus and negative here. So what was I doing? Inverse norm. I don't know if you can hear that. Somebody's talking on Zoom right now, so I'm going to turn that off. 1.960. Oh, sorry. I'm plugging in 0.025 in there. And I got a value that I already knew actually, but if you don't, or if it's a weird, fresh one that you haven't ever seen before, which is on the back of the quiz, I think I'm doing an 85% later on. You have to do it from scratch and get a different z-score for a different confidence level. Let me pause it here. Alright, and we're ready to go. We're ready to put together p hat plus or minus z alpha over 2 times the square root of p hat q hat over n. Alright, again, this is just organizing the pieces I'm going to put here rather than try to figure things out as I put them in. Get it all organized, ready to go first. As a recommendation, p hat plus or minus z square root of 0.516 times 0.484 divided by 800. I'll compute all of this after the plus or minus. That will be my margin of error, which they are going to ask for in the next question, number 2. 1.960 times. And to recap what I'm typing in to do that is, I'm just doing 1.960 times square root. If you have the parentheses one where the roof doesn't extend, make sure you just use one set. There's no need to do little parentheses within there, so I'll do 516 times 0.484, no parentheses, divide by 800, and then a single close for the square root. And I got 0.0346. And this is proportions as well. This is a percent of voters that support the prop. And so that's 3.5%, and we'll just round it off to 3 places, the same as there and there. And that's down to the 10th of a percent. All right, so what I got is 516 with a margin of error of 3.5%. And I'll just get my boundaries by subtracting and adding. 481. When I subtract 0.035, 551, and note that that's the wrong order. Make sure this is in the correct order. It's going to be smallest lower boundary and largest upper boundary so that you can see it on a number line. 481 is the lower bound. 551 is the upper bound, so make sure you're putting in order. That is technically wrong, even though I obviously won't know what you meant. Give it to about an interval, so it's between 48.1% and 55.1%. Okay, that's transfer number 1. Number 2, I'm just going to cram it over here because I don't have to do any work. What is the margin of error on our 95% confidence interval, the one we just did? We did it right here, right there. The margin of error is 3.5%. You can give it in decimal. We'll be working with decimal forms. You can leave it in decimal form. You could in theory give me these as percents. 0.035 is correct. 3.5% is correct. Altered, just a different form of the correct answer. Don't just write 3.5 because that's wrong. That's not the same as this. 3.5% is identical. So I'm more than happy for you to give me that, but you can also just leave it in decimal form. That's what they tend to do in mathematical statistics. Okay, number 3. I will need those because I'm going to refer to it later. Number 3, I put a question like this on the exam. Well, not the exam, one of the practice exams, and everybody gets confused by it because you're so used to having to plug things into formulas. I'm sorry, let me write my answers here. you're so used to having to do a lot of work that when I give you a problem like that, all I want you to do is be able to interpret a media report and relate it to what we just did. We did this from scratch, just being given the information that 413 out of 800 supported it. We got our confidence interval that we got by adding and subtracting the margin of error. And then here, number 3, they're saying that a different competing polling agency reported that in their survey, it has support of 53.7% with a margin of error of 2%. And determine their confidence interval for that survey. All right, so basically, they did most of the work. They computed their percentage, their p-hat. Their p-hat was 0.537. So you don't have to write the whole formula out. We're not going to be using the whole formula. But I just want to kind of emphasize that what they did was they gave you p-hat as 53.7%. We don't know how many out of how many. They did it for us. They're keeping a secret. And they're just giving the output. p-hat, 53.7% of their survey, of their sample, supported the prop. This whole computation here that we did with the square root and whatnot, they also did that for us. They're telling us the margin of error is 2%. So all we have to do is just do that last step, adding subtract, so don't be confused by that. It is actually that easy. I just want to make sure that you can relate that kind of thing, what the media reports, to the actual work that would be involved if you were the actual statistician doing it. All right, 537. Oh, I could have done that in my head. Okay, so they are 95% confident that the true percentage of voters who will support the prop is between 51.7% and 55.7%. Which means that they're 95% confident that it will pass, whereas we are considering the possibility that it might be 49% and might not pass, because it's got to be over 50%. So 50% for passing a proposition is the cutoff, I think, unless I don't know California politics. But anyway, that one says it could go either way, although it does favor passing slightly. That's our point estimate. This one, they're 95% sure it's going to be in that range, so they're over 95% sure it's going to pass. Anyway, moving on to number 4. Number 4 says, if it fails to pass, getting only 48.6% of the vote. So what they're saying there is, so the idea here is, they were 95% confident that the true percentage P is contained in there. We were 95% confident that the true percentage P will be contained in our interval. And it could be in both of them. Both of them could be correct. Or both of them could be wrong, or one could be correct and one could be wrong. So for number 4, they're saying hypothetically, on election day, turns out the true proportion was 48.6%. So they are saying P is equal to 0.486. Which ones contain the true percentage? It's between that one from Acme, what I called it, Acme, and then Berkshire. Which one contained it? Which one did not? And again, they might both contain it. They might both miss it. But let's see. You're looking to see if that percentage is within here. It's tricky with the decimals. People do get it messed up, but I want to visualize it. That top interval was from 0.481 to 0.551. And now you're just trying to figure out where this 486 lies. Is it, basically the confusion is there. Is it below that or is it above that? That's 4, you can ignore the decimal and just think 481 versus 486. Which one is higher? 486 is higher. And so that means 0.486 will be slightly to the right of it. It will be higher, meaning it will be contained in there. So, I'm going to write this. It was contained. It is between 481 and 551. So it was contained in Acme's. That's a check mark, yes. And then the second question, I mean not the second question, but the same question, but the second part is, how about this one? This other competing confidence interval by the competing polling agency. Is 486 within that? That's easier to tell. That's definitely below 517. 51.7 to 55.7, 48.6 is not within there. So you don't have to write all this out. This is me just making sure you can see on the board what I've just been talking through. .486, the true percentage is between there. It is contained in that first confidence interval. So Acme predicted correctly that it would be within there. 486 was not in the second one, Berkshire's. So they were wrong, not because they did anything wrong, but because if they do a 95% confidence interval, there's a 5% chance that they might miss it, and this is the 5% chance that they did miss it. Okay, anyway, your answer here, I guess, I don't care how you answer it. You can give that, but the summary is, how is it worded? Which one contained the true percentage? Acme did. Berkshire, no. Something like that. Just indicate that you know which one contained it. Okay, moving on. Number 5 is a visualization of those two confidence intervals and this concept right here. Plus, apparently there's a third confidence interval that was computed, and they want you to label Acme and label it A for short, and then Berkshire B, and then the third one you just ignore, but there's a third one in there that's thrown in to make sure you can distinguish which one is which. Alright, let me draw that out. Okay, 4, 5, 5, 0, 5, 5, and it goes all the way to 0.60. That first one, and it not only does it have the interval, but it has a point estimate. So it had a point estimate here that I'm going to go with bottom to top. Bottom one looks like it had a point estimate of 5.1 something, and it spans all the way to a little bit past 5.5 and a little bit below 4.8. This next one over here has a point estimate about 4.7, and it spans to just below 5.0, and then I don't care about that side. Last one, 4.8-ish. Oh, 5, my bad. 5.3 something. It spans to 5.1 something. Okay. And then they have the actual percentage, 48.6%, what I was just mentioned here. They have it labeled there, and it goes through, meaning that they didn't label it here, but that's your 486. That's what that vertical line was for. I did something like this in the notes, and I just want you to make sure you can read when a news organization collates a bunch of confidence intervals done by different polling agencies talking about an election or some sort of political proposition. You can kind of see how they're setting it up so that you can see that visually this one contained it, they contained it, that one contained it, this one did not. So based on the fact that this one did not, it's probably Berkshire. But let's go through it more carefully just to be sure. I'm going to do Berkshire first. 517, 557. So you're looking for the one that spans from 517-ish, which is about here, to 517 to 557. So about here to here. That's the only one that makes sense. That is Berkshire for sure. Going back to Acme, 481 to 551. 481's a little bit below this. 551's a little bit below that. That's that right there. Okay. And then this one is some third polling organization that predicted that it would be about 46 or 47%. Anyway, that organization was correct. It did contain it. That's Acme. Berkshire was wrong. They missed it. This other organization did correctly predict that it would be within there. All right, that's it. Just want you to visually be able to understand how these get translated onto a picture like this. Number 6. 6 is a different sort of problem. These are all from 8.1. Number 6 is moving on to 8.2 because they want the minimum sample size needed so that the margin of error is at most 2.5%. I'm going to erase over here. We're done with these. assume we have no information about the proportion of voters that support the prop. So your formula, you don't have to derive it from scratch every time. You can just go to your formula, which is that n needs to be at least or greater than PG, which stands for a guess at P. 1 minus PG, and you have no information, so you're going to have to take a guess that is based on no information. I mean, not really a guess, but the idea is we don't know it. Okay, and that's what we're doing, and then just making sure we round up so that our n is bigger than that. Just make sure you understand that you are not putting 0.516 in there. It's not related to that actual poll that they took in number 1 or number 4 or any other poll, because this is starting from scratch, saying we don't know how, we haven't taken a survey yet. We want to know how many people to survey. We want to know the minimum sample size. So we haven't gathered any information or surveyed anyone yet. So you can't be using percentages from the previous problem. They want you to assume you have no information. And when you assume you have no information, the way to guarantee that your n will keep your margin of error under 2.5% is to use 0.5 for your PG, and then 1 minus PG is 0.5. So for this type of problem, minimum sample size problem, always 0.5, 0.5. The only thing you're going to do is the Z is relevant to the confidence level. They're saying they want it for the 95% confidence level, and so that was a 1960 that we used for a 95% confidence interval. The margin of error E is that's what they're specifying in the problem. They want at most 2.5%. And that's a very common thing that they go for. They like to have a margin of error about 2.5%. Why? I don't know why, but I will mention, because it does come up in the homework, when you have a margin of error of 2.5%, that means you get a confidence interval that is how wide? The width of a confidence interval is just how far from the lower bound to the upper bound. And if it's got a margin of error of 0.025, 2.5%, that means your width will be 5%. Maybe that's why they go for it, because it's a nice round 5% width. Okay. Anyway, that's not the problem. The problem is to get this minimum sample size. So let's go ahead and do that. 0.5 times 0.5 times, in parentheses, don't forget the parentheses around the whole thing, so that both the 1960 and the 025 get squared. That square applies to both. I got 1536 point something something. It doesn't matter what that is. You're not going to look at that and round up or down based on that digit to the right. You're always going to round up. You need it to be bigger than that, the next highest whole number. So it's going to be 1537. Doesn't matter what decimals you see there, you're always going to round up. They are 64, so you will round up anyway, but just beware. If that's a 1, you're not going to round down to 6. You are still going to round up to 7, because this is a rule where you need n to be greater than whatever this is. Okay, anyway, that's your minimum sample size to get your margin of error to be at most 2.5%. I mentioned that's what they like, and that's why they usually survey 1,500 people at least. That's a very typical sample size for a political poll. All right, we're going to do the last problem, which is just a weird, I just wanted you to do one weird confidence level. So we're going to do 85% confidence level. I'm going to pause it because somebody's texting me. Okay, last problem. I'm going to do a minimum sample size problem for number 8, but for number 7, a confidence interval for the percentage of households with internet access. So it says to calculate an 85% confidence interval. First question, proportions or means. Are we doing proportions of things, percentages of things, or averages of things? Again, it's percentages of households. So it's proportions. That's our formula for the confidence interval for proportions. I need, as before, p hat, q hat, n, and z off over 2 for 85% confidence level. So I'll have to spend some time, not too much, but that's a weird one that we haven't seen yet. Anyway, p hat I gotta compute from scratch again. 606 out of 843 this time. 3 places for proportions. Q hat 1 minus that is 281. N is 843, not the 606, but the 843. And then my z-score. Alright, let me do this. I gotta find that z-score that creates a symmetric interval about the origin on your standard normal curve that contains that confidence level inside. 85% confidence, I want bound by those. I gotta find the tail probabilities. 1 minus 0.85 will give me 15% outside of that, meaning 15% of both tails combined. I'm going to divide that by 2, and I will get 7.5% in each tail. 7.5% on the right tail, 7.5% on the left tail. That together adds up to 15%, plus 85 in the middle adds up to 100%. And that's what I need to do for inverse norm. Enter the tail probability. Be careful not to type in 0.75. It's 0.075. And it'll give me a negative, it'll give me this side negative value, specifically negative 1.4395. Let me write it out. I'm going to run it at that 9, but there's a 5 to the right of it, so I got to bump that 9 up by 1. It's going to be 10, carry a 1, 4, 4, 1.440, negative 1.440, positive 1.440. Technically, the critical value is a positive 1, although again, it doesn't matter because we'll be doing plus or minus that times other stuff anyway. Let me put it together right here. Our point estimate 719 plus or minus z times what's called my standard error, which I get by doing 0.719 times 0.281 divided by 843, all under the square root, and that right there is called my standard error, multiplied by my z-score for that confidence level. But when I type it in, I'm going to type in the entire margin of error. Standard error, whole thing is margin of error. You get 93, wait, what did I get? What? Oh man. 0.0222, so it's going to round down, 0.022. Okay, and I got 697 and 741. What does that mean? It means we are 85% confident that the true percent of households with internet access is between 69.7% and 74.1%. All right. I think I might have used somewhat real data, or you gave it a real estimate, but that was a couple of years ago, so hopefully it's higher now, and hopefully everybody is doing okay with internet access. But anyway, I didn't write this problem related to the current situation. It's a coincidence that it's relevant. Number 8, minimum sample size. Oh, I erased it, but it's the same formula. PG, 1 minus PG. I'm still using 0.5, 0.5. I'm not using anything based on that sample because this is intended to be for a fresh start. We are going to be taking a new survey of an unknown number of people. We want a sampling error of at most, margin error of at most 4.5%. We don't know how many people to survey, so we don't have any other information about specifically the proportion that we need here. So we're just going to use 0.5 as always for this type of scenario. My z is for an 85% confidence interval, it says. That z-score would apply for any 85% confidence interval. So that's consistent. That we do pull from our previous work, or do it fresh if we need to. Margin of error, 4.5% is 0.045. We're going to square that, and then always round up. No need to round though, because I can throw it exact 256, so we're good with that. I know technically that's not greater than, I shouldn't put it like that, but I'm not getting picky about that one. And none of this works out exactly, so you don't have to worry about that. But if you have to round, always round up, but if you don't have to, don't worry about it. Leave it as it is. 256 will be sufficient to guarantee our margin of error is under 4.5%, or at most 4.5%. Okay, that's it for quiz 8.1, 8.3. Then, sorry, 8.1, 8.2. 8.3 is on confidence intervals for means. Different formula, but a lot of the concepts hold over. You'll be using t instead of z. You'll see the lecture, and we'll do it on the next quiz. We'll get some practice with that as well. All right.